So good morning, welcome to EduMath Zone. Welcome to the real numbers revision series. So today we shall discuss real numbers. Real numbers, first chapter. Revision part. Revision. Okay. Lakshmi, good morning. First question. Using Euclid's division algorithm. Find HCF of 408 and 128 and 128 and 128. This is the question. So welcome Mahesh. Okay, so let us find out now. So first, what shall we do now? Here the highest number is 408. The 408 divided by 128, right? 128. Now 128 two times you try. This is 16, 5. This will be 256. 128 three times. 24, 6 plus 2, 8, 384. Now 3 times 384. So you subtract it. Now what do you get now here? 4. 10 minus 2 is 8. So 24 you will be getting. Am I correct now? So that means now here 408 equals to, we can write 128 into 3 plus 24 you can write. Say equation 1. Now you divide this 24, 128 with 24. 24, okay, 24, 6 ja, 6 4 ja, 24, 6 2 ja 12, 144. So 24 5 ja, 20, 110 you can write. So 5 times, this will be 110, 8, this will be 18. So that means 128 can be written as this 128, 24 into 5 plus 18. Say this is equation 2. Equation 2. Now, okay, now 24 divided with 18. 18 1 ja 18. You get 6. So that means now the 24 can be written as 18 into 1 plus 6. This is third equation. Now you take 18. This 18 can be written as, if you divide 18, see, 6. 6 3 ja 18. You stop, remainder is 0. So that means 18 can be written as 6 times 3 plus 0. So you need to continue till you get the remainder 0. So now this 6 is the SCF. So now therefore Therefore, HCF of 408 and 128 equals to 6. This is the answer. So this method is called actually using Euclid division algorithm method. So you might have followed this one. You need to follow like this. Kishore. Okay, right. Next, second question. Second question. Prove that 847 and 2160 are co-prime using Euclid's division algorithm. So very simple. Here see, prove that 847 and 2160 are co-prime means it is enough to prove that HCF of these two numbers is 1 using division algorithm. That's all. Find SCF of these two numbers itself only. That means actually bigger number is 2160. Divide with 847. First you try 847 times 2. 7 to the 14. 4 to the 8 plus 1 9. That will be 16. So 2 times it goes 2 times. 1694. Subtract, you will be getting 6 because 10 here. Here this will be 15, 10. Okay, this will be 1. 15 minus 9 is 6, 466. So that means here solution you can write like this. Now the 2160 can be written as 847 multiplied with 2 plus 466. Say equation 1. Now you need to take these two values. You need to take these two values, 847 and 466. So now what shall we do now here? Now 847 divide with 446, 466. 466 2 ja, you try 12, 13, 932. It will be more. So 466 1 ja 466. Subtract. So what do you get now here? So you get 1. It cannot go. So take borrow 10, becomes 7. 14 minus 6 is 8. 381. So that means 847 can be written as 466 multiplied with 1 plus 381. Say this is equation 2. Now we need to apply algorithm on both these two numbers. So now the 446 is divided by 381. 381 1 jar right out. 381. Subtract, you will be getting 5. So borrow 10, 14, it will be 3. 14, that means 60. 14 means 8 plus 6 is 14, 65 you will be getting. So that means we can write this 446 equals to 381 times 1 plus 65. This is equation 3. Yes, 446. Okay, right. 446, not sir, 466. So let us try. I will try once again. So 2160 divided by 847. 847 2 ja. 847 times 2. 14, 9, 16, 94. 6. This will be 5. 15, 6, 4. Yes, 466. Exactly correct. 466. Right. 466 will have written 466. Yes, yes, yes. Here 466. Absolutely correct. Absolutely correct. This is 466. Okay. So now 847 divided by 466. 466 1 ja 466. This is 1. Now take borrow 10. It will be 7. 14 8. Next 381. 847 can be written as 710 multiplied 1 plus 381. This equation 2. Now apply on 710 and 381. 710 divided by 381. 381. So 1 ja 381. So borrow 10. Here 10. This will be 6. 9, 2, 329. So now we can write 710 equals to 381 times 1 plus 329. This equation 3. Now 381 divided by 329. So 1 ja 329. Borrow 10. We have here 7. 11 minus 9 is 2. 552. So that means 381 can be written as 329 multiplied with 1 plus 52. So this is equation 4. Okay. Now what do you get now here? Let us see. So now 329 divided by 52. So try with 52 6 times. 6 2 ja 12. 312. Yes, 6 ja 312 you will be getting. Subtracting 7, 37. So that means 329 equals to, we can write 52 multiplied by 6 plus 37. Say equation 5. This is. Now the 52 should be divided with 37. 52 divided by 37. 37 1 ja 37. So this will be 12, 4. So 12 minus 7 is 5, 15. So that means 52 can be written as 52 37 times 1 plus 15. This is sixth step. Now 37 is divided by 15. 15 3 ja 15 2 ja 30. We have 7. So 37 equals to 15 into 2 plus 7. This is seventh step. Now 15 is divided by 7. 7 2 ja 14. So you have one remainder. So that means 15 equals to, you can write 7 into 2 plus 1. Say this is eighth step. Now last step is, you can write 7 divided by 1. 1 7 ja 7. 0 remainder. So that means last step I will write here 7 equals to 1 times 7 plus 0. This is ninth step. say 1. This 1 is the SCF. SCF of 847 and 2160 is 1. Okay. Is 1. Therefore, they are co-prime. They are co-prime. This is the answer. So very good morning. Very good morning. So now the third question. Prove that 7 into 11 into 2 plus 7 into 5 is a composite number. Is a composite number. Is a composite number. Okay, let us solve it now. How could you solve composite number? So composite number means it should have at least more than two factors. At least more than two factors. Then we say that that is a composite number. Okay, right. Here solution you see. Now consider 17 into 11 into 2 plus 17 into 5. Here see the 17 is the common. This you can take out common out. If you take 17 common out, we have like this 1 into 11 into 2 plus 1 into 5. So you simplify it now. This equal to 17 times 22 plus 5. This is 17 into 27. This 27 factors also you can write. See 3 9 ja prime factorization 3 3 ja. So that's why you can write this 17 times you can write 3 cube you can write. So it has more than two factors. So therefore it is a composite number. It is a composite number. It's not a prime. Fourth question. Prove that 7 into 11 into 13 minus 3 is a composite number. Is a composite number. Composite number. So prime number means it has only one and it same number is its factor. But composite number means it's more than two factors. So that means now solution. Consider 7 times 11 times 13 minus 13. Here take 13 common. We have 7 into 11 into 1 minus 1. Let us simplify. 13 times you will be getting 77 minus 1. That is 13 times 76. Now let us find factors of 76. See 2 3 ja 6, 7 minus 16 to 8 ja. Next 2 19 ja. 19 is a prime number. Stop. So its factors are 13 into 2 square into 19. So hence it is a, therefore it is a composite number. It is a composite number. Is it a composite number? Fifth one, show that 13 into 17 into 19 plus 23 into 38 is a composite number. Is a composite number. Can you prove this one? Okay. Solution. Consider 13 into 17 into 19 plus 23 into 38. So now take this from 38, take 17, this 17 common, you can take out 17 common. So this is equal to, we can write 17 common, 13 into 1 into 19 plus 23 into, sorry, not 13, 19 common, you take 19 common. So 19 common, you get like this, 13 into 17 into 1 plus 23 into 2. So now 13 into 17, 91, 17 3 ja, 91, 13. This is 1, 12, 221. So 19 times 221 plus this will be 46. Add 46. 7, 267 you will be getting. So 19 into 267. So it has two factors. So that's why it is not a prime number. Therefore, it is a composite number. It is a composite number. Composite number. Even further, 267 also we can write like this. 3 8 ja 24, 27, 3 9 ja. That means we can write like this also. 19 into 3 into 89 also we can write. Still it has more factors. It's enough 3 factors we have written as a product of. So it is a composite number. Sixth question. Okay. Write the decimal form of the following rational numbers without actual division. In that, first question is 7 upon 8. So this is very important question. Here write the decimal form of the following rational numbers, a condition, without actual division, without dividing 7 by 8, you need to convert into the decimal form. This is a fraction form. You need to express into the, it's a rational number. Actually p by q form. This p by q form should be put in decimal form. So without division. So how should we do it? Let us do it, proceed then. So now the given is actually here, write down 7 upon 8. First prime factors of 8 you find out. What are the, how to find out prime factorization? Start with 2, 2 4 ja. Next 2 2 ja. This 8 can be written as 2 into 2 into 2. So this equals to 2 cube. Now this can be written as 7 upon 2 cube. So 7 upon 2 cube means, so multiply both numerator and denominator with, whenever 2 cube is there, divide with 5 cube. Suppose here 5 cube is there, multiply both numerator and denominator with 2 cube. So vice versa. So that means this we can write 7 upon 2 cube multiplied with 5 cube upon 2 cube. 5 cube. Indirectly 5 cube cancel, multiplying with 1 only. So it makes no difference. 7 multiplied by 5 cube is equal to, you see 5 cube, 5 into 5 into 5 into 5. 5 into 5 is 25, 25 into 5. 5 5 ja 25, 5 2 ja 10, 125. This is 125. So we have one more formula. For example, a power n into b power n is there, that we can write a into b, ab all to the power of n. So this we can write 2 into 5 whole cube we can write. So 125 into 7 write down. 7 5 ja 35, 7 2 ja 14, 14 plus 3 is 17, 7 1 ja 7, 875. So this equals to 875 upon 5 2 ja 10, 10 cube. We can write 10 cube. So that means 875 by 1000. Very simple to write in decimal form. First in the numerator whatever digit, the digits write down, 875 write down. Here how many number of zeros are there in the denominator? 1 2 3. So now from right to left count the 3 numbers, after that put the decimal point. 1 2 3, you put the decimal point here. So therefore 7 by 8 equals to 0.875. So like this you need to do it. You might have understood now. So next in that one we have second question. Without dividing you need to convert into the, change into the decimal form. 15 upon 16. 15 upon 16. So what is the solution? Here or consider first step, 15 upon 16. So here this is numerator, denominator. Denominator is 16. Prime factors of the 16 let us find out. What are the prime factors? Start with 2, 2 8 ja. Next 2 4 ja. Next 2 2 ja. So that means 16 can be written as 1 2 3 4. 2 into 2 into 2 into 4 times. 2 raised to 4. So this can be written 15 upon 2 raised to 4. So now multiply both numerator and denominator with 5 to the power of 4. 5 to the power of 4. So now what do we get now here? 15 upon 2 to the power of 4 multiplied with 5 raised to 4 and upon 5 raised to 4. First let us find out 5 raised to 4 value, this value. 5 raised to 4 equals to 5 into 5 into 5 into 5. 5 into 5 is 25, 5 into 5 is 25. 25 into 25 is 625, 25 square. Please remember, 25 square. 25 square is equal to 625. So this is 15 times 625 upon this we can write 2 into 5 whole to the power of 4. Now 625 is multiplied with 15. 5 5 ja 25, 5 2 ja 10, 12, 5 into 6 30, 31, multiplied with 5, 1 into 5 5, 1 into 2 2, 1 into 6 6, add 5, 7, 3, 9. So this equal to 9375 upon 10 to the power of 4. Don't expand it because 10 to the power of 4 means it has 4 zeros. 10 cube means 3 zeros. So now 9375 write down. It has 4 zeros. 10 to the power of 4 means count 4 numbers from right to left. 1, 2, 3, 4. After that put the point, 0 point. So therefore we can write 15 upon 16 is equal to 0.9375. So it has been expressed in decimal form. Next, third question. 46 upon 2 cube into 5 square. 2 cube into 5 square. So just expect it. Already the denominator has been expressed as the product of the 5 factors. But here one thing is there. Here 2 cube is there, 5 square is there. We need to make this is 5 cube. That means multiply both numerator and denominator with 5. Enough. You will get the answer. So let us see now here. Solution. So consider 46 upon 2 cube into 5 square. Multiply both numerator and denominator with 5. So you get like this. 46 upon 2 cube into 5 square multiplied with 5 upon 5. Now 46 into 5. 5 6 ja 30, 5 4 ja 20, 230. This will be 230 upon 2 cube into 5 square into 5, 5 cube. This we can write 230 upon 2 into 5 whole cube. So this equals to 230 divided by, this will be 10 cube. 10 cube. This we can write 230. How many points? 3 points. 1, 2, 3. Put the point here. So 0.230 means point after any 0 it's not valid. You can remove this 0. 0.23. So therefore the 46 upon 2 cube into 5 square equal to 0.23. Yes, with just for Rupini. Absolutely correct. One minute. Now 7th question. Find the value of, or evaluate, or determine, whatever you can say, no problem. Find the value of, first question, log of root a to the base a. This value we need to find out. See the solution. First question, log of root a to the base a. This root a can be written as a to the power of 1 by 2. The first step. So this is equal to log a to the power of 1 by 2 to the base a. And we have one more formula. Log x to the power of n to the base a. Power rule. This we can write n times log x to the base a. So this equals to, we can write half times log a to the base a. And one more formula we have. Logarithm of same number to the same base itself. Log a base a is 1. So half into 1. So answer is 1 by 2. So you might have understood this question. Okay, next let us move to the second question in this one. Second question. Log of 1 upon 81 to the base 3. Okay, 1 upon 81 to the base 3. Here the solution, log of 1 upon 81 to the base 3. First 81, prime factors of 81. 3 27 times, 3 9 times, 3 3 times. So 81 equals to, we can write 3 raised to 4. But we have there 1 upon 81. 1 upon 81 means 1 upon 3 raised to 4. That equal to 3 raised to negative 4. So this we can write log of 3 raised to negative 4 to the base 3. So we have the formula. Log x to the power of n to the base a equals to n times log x to the base a. This we can write minus 4 times log 3 base 3. This log 3 base 3 is 1. So minus 4 times 1 equal to minus 4. This is the answer. Yes, absolutely correct. Minus 4. Next, third problem. 3 to the power of 2 plus log 2 base 3. Log 2 base 3. Log 2 base 3. Here solution, 3 to the power of 2 plus log 2 base 3. See, we have one formula, a to the power of m plus n. This we can write a to the power of m into a to the power of n. It's the first step. So this we can write, here a is 3, m is 2. 3 square into 3 to the power of log 2 base 3. And we have one more interesting formula. What is the formula? A to the power of log n to the base a is there. A. Then you get n value. Here see, 3 to the power of log 2 base 3. Here n means 2. Directly this value becomes 2. So this equals to, we get now 3 square is 9 times 2. So answer is 18. Answer is 18. Now, fourth problem. Log of 0.001 to the base 10. The value of this one we need to find out. So value of this one we need to find out. Right. Solution. Log 0.001 to the base 10. Here see, 0.001. This is the decimal form. So decimal form you need to write in the fraction form. 1 by, you can write 1000. So this 1000 you can write 1 upon 10 cube. 1 upon 10 cube is 10 to the power of minus 3. So that means this equals to, we can write log 10 to the power of minus 3 to the base 10. So we have the formula log x to the power of n to the base a. That is n times log x to the base a. Log x to the base a. This we can write minus 3 times log 10 to the base 10. See, log a to the base a is 1. So this can be written 1. So minus 3 times 1 equal to minus 3. Right, Vijja Swarupini. Now fifth problem. Log of sine 90 degrees to the base 10. It's very interesting problem. Log of sine 90 degrees to the base 10. See, first sine 90 degrees we need to write it. See, sine 90 degrees from trigonometry already we have studied. Sine 90 degrees is equal to 1. This equals to log 1 to the base 10. We have one very important formula. Logarithm of 1 to the base, any base, a is equal to 0. Logarithm of 1 to the base 10 is also 0. Answer is 0. Answer is 0. Now eighth problem. Okay. Simplify. First problem. 2 log 3 plus 3 log 2 plus log 5 minus log 12. Okay. Here see the solution. 2 log 3 plus 3 log 2 plus log 5 minus log 12. So first 12, let us write in the prime factorization form. 12. 2 6 ja, next 2 3 ja. So otherwise I can do another method. Okay, leave it now. So we need to simplify. Take the power back. Log 3 square you can write plus log 2 cube we can write. This we can write see, we have one formula. Log x minus log y. This we can write log of x by y. This is a formula we have. Quotient rule. This is called quotient rule. Apply quotient rule on these two. We can write log of 5 upon 12. So again next step, this log 3 square is log 9. 2 cube is 8. 2 into 2, 3 times. Log 8 plus log 5 upon 12. This we can write as a single logarithm. Log of 9 into 8 into 5 upon 12. So now you see 4 3 ja, 4 2 ja. Next 3 1 ja, 3 3 ja. So this is equal to 3 into 2, 6, 6 into 5, 30. Log 30. This value is log 30. That's all. Now second one. Simplify or find, you can write. find the value of log 1 to the base 10 into log 2 to the base 10 into log 3 to the base 10 into so on log 10 to the base 10. It's very interesting problem. Very interesting problem. See the solution. We are asked to find out log 1 to the base 10 into log 2 to the base 10 into log 3 to the base 10 into so on log 10 to the base 10. So here one interesting factor is that log 1 to the base 10 is always 0. That means 0 multiplied by log 2 base 10 into log 3 to the base 10 into and so on. Before 10, 9 will be there. Log 9 to the base 10 into log 10 base 10 is also 1. But 0 multiplied by everything is 0. 0 multiplied by something. So you get 0. Answer is 0. Yes, yes, yes. So now the ninth question. Ninth question. In that first one, check whether log 2 base 10 is rational or not. Check whether log 2 base 10 is rational or not. It's a rational or not, we need to check. So now otherwise prove that log 2 base 10 is irrational. That question is also correct. Solution. So let us assume that it's contradiction method you follow. Let us assume that log 2 base 10 is rational. Let us suppose that log 2 base 10 equals to P by Q, where P comma Q are co-primes, or Q does not equal to 0 also we can write. So this is the logarithmic form. You need to write exponential form. So we can write 2 is equal to 10 to the power of P upon Q. Raise powers to Q on both sides. So what do you get now here? 2 to the power of Q equal to 10 to the power of P by Q, 1 to the power of Q. This Q gets cancelled. We have 2 to the power of Q equals to 10 to the power of P. So that means actually here, see, 2 to the power of Q will not end with 0, but 10 to the power of P always ends with 0. So that is 2 to the power of Q does not equal to 10 to the power of P. It cannot be possible. So therefore log 2 to the base 10 cannot be put in the form of P by Q. Hence our assumption is wrong. Therefore, log 2 base 10 is not rational. It is irrational. It is irrational. Now second one. So now we need to check log 100 to the base 10 is a rational or irrational. We need to check. It's very simple solution. Log 100 to the base 10. This we can write log 10 square to the base 10. So we have log x to the power of n to the base a. That is n times log x to the base a. So this we write 2 times log 10 to the base 10. Log 10 to the base 10 is, this is in the form of log a to the base a, that is 1. So 2 times 1 equal to 2. 2 is a what kind of number? Therefore log 100 to the base 10 is a rational number. It's a rational number. It's very simple. This is very simple. Now third one. We need to check log 8 to the base 2 is rational or irrational. So we can check this one. See, this solution we can write log 8 to the base 2. This 8 can be written as like this. 2 4 ja 8, 2 2 ja 8 equal to 2 cube we can write. This equals to log 2 cube to the base 2. So we have power rule. What is the power rule? Log x to the power of n to the base a is n times log x to the base a. This is 3 times log 2 base 2. Yes, rational number. Log 2 base 2 is 1. 3 times 1 equal to 3. Therefore, log 8 to the base 2 is a rational number. Rational number. Clear, Nana? Understood all of you? Right. So now the 10th question. 10th question. If log 27 to the base 3 plus 3 to the power of log 7 to the base 3 equal to x, then find the value of x. Find the value of x. Find the value of x. So just read the question carefully first, all of you. Okay, first here see log 3 to the log 27 to the base 3, 3 to the power of log 7 to the base 3 is equal to x. That means the value of this one we need to find out. That's equal to x only. So here see solution. Here given, this is given, this part is given. X equals to log 27 to the base 3 plus 3 to the power of log 7 to the base 3. So first, this 27 can be written as 3 cube. 3 into 3 into 3. Am I correct? 3 cube. So here this step we can write log 3 cube to the base 3 plus 3 to the power of log 7 to the base 3. So we need to apply the two formulae. What is the formulae? Log x to the power of n to the base a is equal to n times log x to the base a. This is the first formula. Next, this formula is next a to the power of log n to the base a is n. So that means we need to apply, this is 3 times log 3 base 3 plus this we can write, this 7 we can write. This log 3 base 3 is 1. So this is 3 times 1 plus 7. 3 plus 7. So that is 10. So therefore x is equal to 10. Okay, Swarupini, absolutely correct, your answer. So 11th question. If x equals to log 2 base 3 and y equals to log 5 to the base 3, then express following in terms of x and y. First question is log 90 to the base 3. Log 90 to the base 3. Yes, log 90 to the base 3 should be expressed in terms of x and y. That means first of all we need to express in terms of log 2 to the base 3, log 5 to the base 3, so that we can replace log 2 base 3 by x, log 5 to the base 3 is by y. That means we need to do the prime factors of 90. Let us find out prime factors of 90. So first start with the 245 ja. Now the 45 cannot be divisible by 2. Try with the 315 ja. Again 35 ja. Stop, 5 is a prime number. That means 90 can be written as 2 power 1. Okay, 2 power 1 or 2, 3 square into 5. So that means now the solution follows like this. Log 90 to the base 3 can be written as log of 2 multiplied by 3 square multiplied by 5 to the base 3. We can expand it. This we can write log 2 base 3 plus log 3 square to the base 3 plus log 5 to the base 3. So these two we cannot write, but this we can simplify. So the log 2 base 3 is x. This we can write x plus this we can write 2 times log 3 base 3 plus this we can write y. Log 3 base 3 is 1. So x plus 2 times 1 plus y. So this can be rewritten x plus y plus 2. This is the answer. That means log 90 to the base 3 has been expressed in terms of x and y. That's equal to x plus y plus 2. So you might have understood this step. Okay, second question. Shall I move to the next question? In 11th, second question. So now the second question. Okay, now that is log 270 to the base 3. Now the solution. Log 270 to the base 3. So okay, Swarupini, Lakshmi, what about others? 270. So now 2 1 ja 2, 2 3 ja 6, 2 5 ja 3 4 ja 12, 3 5 ja. Next 3 15 times. Next 3 5 times. So 270 can be written as 2 into 3 cube into 5. Okay, right? So now this can be written like this now. This equal to log of 270. In the place of 270, you write this value now. 2 multiplied by 3 cube into 5 to the base 3. This we can expand like this: log 2 base 3 plus log 3 cube to the base 3 plus log 5 to the base 3. Since we have log 2 base 3 equals to x given, that log 5 to the base 3 equals to y we have. So let us, very good, good try. This is x plus 3 times log 3 base 3 plus this is y. Log 3 base 3 is 1. So x plus 3 times 1 plus y. This can be written x plus y plus 3. Now the 12th question. Show that following can never end with the digit 0. In that first question we have 4 raised to n. Is there actually n is a natural number, you remember? N belongs to natural number, you remember, like this. N is a natural number. See this question, first of all, consider 4 raised to n. First prime factors of 4 write down. 4 we can write 2 into 2, that is 2 square. So this is 2 square all to the power of n. 2 to the power of 2n you can write. Since this, it contains only 2. If it is contains 2 and 5, then it ends with 0. Write down, since 2 to the power of 2n does not contain or does not contain the factor of 5. So 4 to the power of n does not end with digit 0. That's all. It's completed. So other than 2 and 5, it should not contain other factors also. It must contain 2 and 5 both. Then only it ends with 0, because 2 into 5 becomes 10. 10 means 10 to the power of something is 0. So that's why, since 4 to the power of n does not actually contain the factor of 5, so this does not end with the digit 0. So this is the actually reason you need to give it in the examination time. Right. So next, go to second question now. Second question. 6 to the power of n. Can 6 to the power of n end with a 0? Let us check the solution. 6 to the power of n. 6 to the power of n means 6 factors. 2 times 3. This we can write 2 times 3 whole to the power of n. This is 2 raised to n and 3 raised to n. So 2 raised to n cannot end with 0, even 3 raised to n also. Since 6 raised to the power of n does not contain the factor of 5. So 6 to the power of n cannot end with digit 0. Next, third question. 12 to the power of n. 12 to the power of n. 12 to the power of n. See the solution. 12 to the power of n. Here 12 we can write 2 times 6, 2 times 3. This 12 we can write 2 square into 3. This can be written 2 square into 3 whole to the power of n. This we can write 2 to the power of 2n into 3 to the power of n. It does not contain the one of the factors 5. So since 12 to the power of n does not contain factor of 5, so 12 to the power of n cannot end with digit 0. So thank you. We shall continue tomorrow. Tomorrow discussion. Actually, day after tomorrow, this we shall complete this chapter total, including objective type questions. Also, we shall discuss revision point of view. This is the revision point of view. Just go through your textbook concepts, introduction also. Be ready with tomorrow class. Tomorrow 5:10 to 6:10. Thank you. Bye bye.